Back. So today we'll start a physics series, right? So as I have promised, I'll be doing one math series and one physics series. So we'll be starting physics today, and we'll be starting a very important, like you know, we'll be starting a very important physics series today. All right. So this, I'm pretty sure everyone might have heard these terms at least once in their life, right? So first we'll talk about motion, right? We'll be studying motion in 1D, motion in 1D, right? So we'll discuss all the probable cases for motion in one dimension, right? Couldn't write this properly, just give me a minute. Right, yeah. So we'll be studying motion in 1D. So we'll be studying two cases here. One is displacement and one is distance, right? So one is distance, another one is displacement, right? Now let us say you're standing at this point. Let us say this point is A and you have to move to point B, right? So there are three paths to move here, right? First thing, you can go in a straight path like this, right? And you can go like this too, right? And you can move randomly too, right? These are the three probable ways. Let us say this is point 1, this is second, this is the third way, right? So I would like to ask you a question, which is displacement and which one is distance, right? So what would your answer be here, right? So we know displacement is nothing but the shortest path, right? So you would say this is displacement, right? So the answer for this is both 1, 2, 3, all three are distance, right? So because basic definition of distance is basically the path you take to travel from initial point to final point, right? So all these three can be path 2, but out of all these three paths, you see the second path is the shortest, right? This second path is the shortest to go from point A to B. So this is nothing but displacement, right? So displacement is nothing but the shortest distance, right? Now we'll understand the difference between these two, right? So let us have distance here and displacement here, right? So distance is basically a scalar quantity, right? That means it only has magnitude, it has no direction, right? But displacement, it's a vector quantity, right? It's a vector quantity. Now if we compare their unit, right, both unit of both is in meters, right? This is also meters and this is also meters, right? And what is the next criteria? The next criteria is that distance, like we know it's a scalar quantity, right? So it only has magnitude, right? Has both magnitude and direction. Displacement has both magnitude and direction. Now there is one more criteria. This is not dependent on sign, not dependent on the direction, you can say. This is direction dependent because it's a vector quantity, right? So these are the key differences between distance and displacement, right? So we'll solve on one small question, right? So the question is, now let us say there's a guy. Now this is one point A to B. Yeah. So let us say this is nothing but this is 10 meters and even this is 10 meters, right? So your question is, find distance and displacement and what is the ratio. This is the question, right? So now let us solve this. It's a very easy question. Now this is the initial point, that is A, and this is the final point B, right? So now if I want to travel this path, I can travel this way, right? I can travel this. So this is the distance So distance is nothing but 10 plus 10, that is 20 meters, right? Now, but if you talk about displacement, we have to, it's the shortest path, right? So can the shortest path be something like this? Can I say this is displacement? Because this is the shortest way to represent this, because if you go like this or like something like this, that is not a shortest path, because there is some point there. So this is the most perfect shortest path from point A to B, right? Now we know that by Pythagoras theorem, we know AB square, let us say AB square plus BC square, right? So rather than just confusing you, I'll explain Pythagoras theorem. Let us say this is A, this is B, and this is C, right? So Pythagoras theorem says that C square is nothing but A square plus B square. So in this case, the value of this one would be 10 square plus 10 square, right? So if you write this is nothing but 200, right? 10 square plus 10 square is nothing but 200. 100 plus 100 is 200, right? So now how do I write 200, right? So can I say this is 200 or root of 200, right? Now if I take 2 outside, it would be 10 root 2, right? So then can I say that the displacement is 10 root 2, right? Am I correct now? Right. So this is the correct answer. Please forgive me, my laptop is lagging right now. Yeah. So this is the answer is 10 root 2. So what is the ratio? What is the ratio they have asked? What is the ratio from distance to displacement, right? Distance is nothing but 20 meters. 20 is to 10 is to 20 is the ratio, right? When you cut this out, this becomes 2. So this ratio is 2 is to root 2, or we can write it as root 2 is to 1, right? So this is the ratio. I would give a homework question to everyone. Please solve it. I will solve it in the next session, right? So the question is, let us take a semicircle. Yeah. So just 1 minute. Yeah. So let us say this is one circle, and this is the erased region. Okay, I will draw it properly. My bad. So this is nothing but the erased region, let us say, right? This is point A and this is point B, right? So this angle is nothing but this angle 270. Can I take it as 270? Let us take it as 240 degrees. Okay, so this angle is 240 degrees. You have to find the ratio between distance and displacement. All right, so this is a homework. I would be very glad if you all write down the write down the answer in the chat box. Thank you. Bye bye. Take care.